So welcome. Now we continue the lecture series. So now we discuss classification of optical fiber. So optical fibers are classified into three major categories based on the material, number of modes, and refractive index profile. So in that materials, we have glass fiber and plastic fiber based on the modes of propagation, single mode fiber and multi-mode fiber. And based on the refractive index profile, we have step index fiber, graded index fiber. So now discuss all the types. So first one based on the material. So based on the materials in which the fibers are made, it classified into two types as follows: glass fibers and plastic fibers. So glass fibers, if the fibers are made up of mixture of metal oxides and silica glasses. For example, the glass fibers can be made by any one of the following combinations of core and gladding. Core SiO2, gladding P2O3 or SiO2, core GeO2 or SiO2, gladding SiO2. And plastic fiber, if the fibers are made up of plastics which can be handled without any care due to its toughness and durability, it is called a plastic fiber. For example, the plastic fibers are made by any one of the following combinations of core and gladding: polymethyl methacrylate and gladding copolymer, and core polyurethane and gladding methyl methacrylate. And based on the number of modes, the mode is the one which describes the nature of propagations electromagnetic waves in a waveguide. So based on the modes of propagation, the fibers are classified into two types: is single mode fiber, multi-mode fiber. So single mode, general the single mode fibers are a step index fiber. These type of fibers are made from doped silica. It has a very small core diameter so that it can allow only one mode of propagation and hence called a single mode fibers. So the cladding diameter must be very large compared to the core diameter. Thus in the case of single mode fiber, the optical losses in very much reduced. So the structure of single mode fiber, the core diameter 5 to 10 micrometer and gladding diameter generally around 125 micrometer, and protective layer 250 to 1000 micrometer, and numerical aperture 0.08 to 0.10, and bandwidth more than 50 megahertz kilometer. And applications, because of its high bandwidth, they are used in a long haul communication system. And multi-mode, the multi-mode fibers are useful in manufacturing both for the step index and graded index fiber. So the multi-mode fibers are made by multi-component glass compounds such as glass glad glass and silica glad silica, doped silica, etc. So here the core diameter is a very large compared to single mode fibers, so that it can allow many modes of propagate through it, and hence the called the multi-mode fibers. The gladding diameter is also larger than the diameter of the single mode fibers. The structure of the multi-mode fiber, core diameter 50 to 350 micrometer, and gladding of diameter is 125 to 500 micrometer. Protective layer diameter 250 to 1100 micrometer, and numerical aperture 0.1 to 0.5, and bandwidth less than 50 megahertz kilometer. For application, because of its less bandwidth, it is very useful in a short haul communication system. The total diameter of the single mode and multi-mode fibers will be the same. So here the difference in different diameters are compensated in increasing or decreasing the diameter of the protective layers. Thank you. We discuss in next session.